terrifying signals across space. Astronomers have discovered something profound about this huge object using the James Webb Space Telescope. Brian Cox has issued a very serious warning. The question that keeps coming up is, are we about to witness a supernova explosion so big that it will change the night sky forever? In the vastness of the universe, stars are born alive and die in astonishing ways. Recently, one star has captured the attention and concern of both astronomers and the general public. It is Betelgeuse, a red supergiant star that stands out in the cosmic constellation of Orion. A large and very old star. Its reddish color and changing brightness have long been fascinating. But recently, events have made people even more interested in this cosmic giant. As we learn more about Betelgeuse, we are on the verge of a major event in its history. But what could these changes in Betelgeuse mean? Are we seeing the beginning of a cosmic spectacle on an unimaginably huge scale? Betelgeuse is a stellar giant 900 times larger than our Sun. Something difficult for humans to comprehend. Imagine a star so large that if it were to replace our Sun, its surface would reach beyond the orbit of Mars and envelop Mercury, Venus, Earth, and Mars. This enormous size not only shows how impressive Betelgeuse physically is, but also at what stage of its life cycle it is right now. As a red supergiant, Betelgeuse is nearing the end of its life, expanding and cooling in this phase that comes after converting hydrogen to helium in its core. However, the star is believed to be between 8 and 8.5 million years old. It's been changing dramatically over millions of years to become the red giant we see today. It is now in its final stage as a red supergiant. Supergiant stars like Betelgeuse undergo significant changes throughout their lives due to the constant pressures of nuclear fusion and gravity. What makes this stage of Betelgeuse unique is its reddish color. Its red hue is due to the fact that its surface is cooler than other stars like our Sun. While the surface of the Sun has a temperature of about 5,500 Kelvin, the surface of Betelgeuse is about 3,500 Kelvin. Because of this lower temperature, Betelgeuse emits light at a wavelength that makes it appear red. But this color is not just an appearance. It tells us something about the physical state of the star and the processes occurring in its huge gaseous volume. The color of Betelgeuse has changed over time. During the Roman and Chinese eras, Betelgeuse was said to be yellow about 2,000 years ago. In the 9th century, Arab astronomers were the first to claim that it was red. This change in color throughout human and scientific history has also shown how the star has evolved over time. Another interesting thing about Betelgeuse is that its brightness varies over time. It is a variable star, which means that its brightness rises and falls regularly. This variation has fascinated scientists and skywatchers for hundreds of years. Betelgeuse goes through a brightening cycle of 400 days and a longer cycle lasting 5 years. As early as 1836, Sir John Herschel wrote about these cycles, and Aboriginal stories may go back even further. However, what really makes Betelgeuse mysterious is not only how its brightness changes, but also how irregular it can be. Unlike many stars that dim and brighten in predictable ways, Betelgeuse sometimes deviates from this pattern, suggesting complicated and less understood processes within its enormous structure. Recently, astronomers and stargazers around the Dice world were surprised to see Betelgeuse's appearance change dramatically and unexpectedly. This is known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, which is one of the brightest stars in the night sky, and a prominent feature of the constellation Orion, began to dim in a mysterious way. The star was fading at a rate of 0.1 m1 magnitude per day on average. By February twice, Betelgeuse was at its faintest. Normally visible to the naked eye, even in places with lots of light pollution, it had become much fainter and onlookers could tell the difference. However, the paradox of time complicates observing Betelgeuse, as it takes a long time for the star's light to reach us. When we look at Betelgeuse, we see it as it was almost 654 years ago because it is about 654 light-years away. This time lag makes it difficult to predict and monitor rapid changes in its behavior. The Betelgeuse dimming event was a reminder of how complicated it is to observe the night sky in real time and how little we know about this big, strange world of space and time. Andrea Dree, the deputy director of the Harvard-Smithsonian Center for Astrophysics, along with a dedicated team of astronomers and astrophysicists, undertook an in-depth 3-year observational campaign to investigate the extraordinary changes observed in Betelgeuse, one of the most prominent and intriguing stars in our night sky. Their mission was to monitor and analyze the star's outer atmosphere and surface activity using one of the most powerful tools available, the Hubble Space Telescope. This initiative was launched in response to the star's mysterious and dramatic dimming event, popularly known as the Great Dimming, which began in late 2019 and startled astronomers around the globe. The Hubble Space Telescope, with its advanced ultraviolet UV sensing instruments, allowed the team to peer deeper into the complex and dynamic layers of Betelgeuse atmosphere. Unlike optical telescopes, which primarily capture visible light, Hubble's ability to detect UV radiation made it possible to observe high-energy processes and fine details in the star's upper atmosphere that are typically invisible to ground-based observatories. This capability was crucial in providing fresh insights into the physics of variable stars, stars like Betelgeuse that change in brightness due to internal and surface fluctuations. Dupre's team focused on studying Betelgeuse outer layers, which are influenced by turbulent convection cells, immense swirls of hot gas rising and falling on the star's surface. These convection cells play a major role in transporting energy from the star's interior to its surface, where it is radiated into space. During their research, the team analyzed Hubble's spectroscopic data collected during different periods in 2019 and 2020. Spectroscopy allowed them to measure the motion of stellar material through Doppler shifts in the light emitted by the star. What they found was astonishing. Vast amounts of material were being ejected from Betelgeuse's surface at staggering speeds, approximately 200,000 miles per hour. This outflow of gas traveled immense distances, reaching millions of miles into space. The ejected material eventually cooled and condensed into a dense dust cloud, which partially blocked Betelgeuse light from reaching Earth, thus explaining the significant dimming that had alarmed scientists and skywatchers alike. These findings not only demystified one of Betelgeuse's most peculiar behaviors, but also underscored the importance of continued long-term monitoring of variable stars. The insights gained from this study have deepened our understanding of the late evolutionary stages of massive stars and the complex processes that can lead up to a potential supernova. This movement of material contributed to the formation of a dust cloud that made the star appear less bright for 3 months. Dupre and her team thought that about twice as much material from Betelgeuse's southern hemisphere had been ejected. This mass loss was remarkable because it occurred at a much faster rate than expected. The astronomers wondered whether this event might be a sign of an upcoming supernova explosion given how large the mass release was and how faint the star became. At approximately 654 light-years from Earth, Betelgeuse continues to puzzle astronomers with its unpredictable behavior. Despite decades of observation, the true cause behind its recent dramatic dimming and mass ejection event remains uncertain. One of the most fascinating possibilities is that Betelgeuse may be nearing the end of its life, preparing for a spectacular supernova explosion. If such an event were to occur, it would be clearly visible from Earth, even during daylight hours, and would provide scientists and the public with a once-in-a-lifetime opportunity to witness a supernova from relatively close proximity. However, the key question persists. Are we truly witnessing the star's final moments, or was the recent dimming merely a temporary phase in Betelgeuse's long and complex stellar life cycle? Many researchers urge caution, pointing out that massive stars can exhibit such irregularities thousands of years before actually going supernova. Several theories have emerged to explain the sudden changes, including large surface convection events, unexpected mass loss, or even dust cloud formation. Yet, definitive answers remain elusive, keeping Betelgeuse firmly in the spotlight of scientific curiosity. To understand Betelgeuse's future, astronomers are now employing not only the James Webb Space Telescope, JWST, but also ground-based observatories equipped with adaptive optics and infrared capabilities. JWST, in particular, is revolutionizing how we examine red supergiants like Betelgeuse. Its infrared vision penetrates the dust clouds that surround the star, allowing for an unprecedented look at its interior dynamics and surface variability. With each new dataset, scientists hope to refine their models of stellar evolution, narrowing down the timeline for when Betelgeuse might eventually explode. When a red supergiant like Betelgeuse reaches the end of its life, it no longer has the internal pressure needed to counterbalance gravity. The core collapses in seconds, triggering a catastrophic supernova explosion. In that moment, the outer layers of the star are violently ejected into space, creating shock waves and forming heavy elements like gold, uranium, and platinum. These elements are dispersed into the interstellar medium, eventually becoming part of new stars, planets, and possibly even life itself. Thus, while a supernova marks the death of a star, it also contributes to the cosmic cycle of creation. The idea that Betelgeuse could go supernova within our lifetime has sparked global interest, not just among scientists but also among the public. Entire communities of amateur astronomers have taken to monitoring Betelgeuse nightly, contributing valuable brightness data through organizations like the American Association of Variable Star Observers, AAVSO. Social